This video is for reviewing the concepts from 301 through 302 for similar figures. Dilation, a transformation that changes the size but not the shape of a figure. The shape can get bigger or smaller. An expansion is when the figure gets bigger, and a contraction is when the figure gets smaller. Through this dilation of expanding and contracting, the shape stays the same while the size changes. Scale factor in a dilation is the ratio of the length of a side of the image to the length of its corresponding side on the preimage. Remember, preimage is before the transformation. The image is after the transformation. And in this unit, we were talking about dilations. So a figure with a vertex point A in the preimage would be its corresponding point on the image would be A prime. And that's how we read that little A with the little apostrophe there. We read that A prime. So again, the scale factor is image over preimage. An expansion has an absolute value scale factor greater than 1. Example of expansion scale factors would be 2 and -3. A contraction has an absolute value scale factor of less than 1. Examples of those are 1/2 or -2/3. And I will address what the negative represents on a later slide. Here's an example where the preimage ABCD is being dilated, in this case contracted, to the image A prime, B prime, C prime, D prime. In order to determine the scale factor, we would look at the image A prime, B prime, C prime, D prime, the figure to the right, and we would take the side measure, say A prime, B prime, and we would compare that, create a ratio to its corresponding side on the preimage ABCD, and in this case AB would be the corresponding side. So 6:12, which is reduces to 1/2, or we could take the width B prime, C prime, and put that over the corresponding side of the preimage BC, so 4/8 equals 1/2. Question 1. Which figure is the preimage? Question 2. What type of dilation is occurring? Question 3. Determine the scale factor for this dilation. Center of dilation is the point of intersection of lines connecting each point on the preimage with its corresponding point on an image. The center of dilation can be either inside the preimage, outside the preimage, or actually on the preimage. When the dilations are on the coordinate plane, so we can actually look at dilations on the coordinate plane. When the center of dilation is the origin, the point 0, 0, we can use the coordinates of the preimage, in this one, the example right here on the left, A, B, C, D, and multiply them by the scale factor to obtain the coordinates of the image after the dilation. So on the example on the left here, the scale factor is -1/2. So multiplying by -1/2 is the same as dividing by -2. So if I take my initial vertices, A, B, C, and D, and I take my x-coordinate and my y-coordinate for each of those vertices and multiply them, or in this case I'm going to divide by -2, I will again get the new coordinates for the image, A prime, B prime, C prime, and D prime. So 2 divided by -2 is -1, 6 divided by -2 is -3, and so on and so forth. So you can see, in this case, okay, that the absolute value of -1/2 is 1/2, that is less than 1, so this dilation is a contraction. And over here, again, we have a scale factor of 2. We can take our image, ABCD, in this case we're starting with the smaller rectangle, and multiply the x and y coordinates by the scale factor of 2. So 1 times 2 is 2, 3 times 2 is 6. 4 times 2 is 8. 3 times 2 is 6. Again, this only works when the center of dilation is the origin, and so on and so forth. So in this case, it's an expansion. And I had said earlier, the difference between a negative scale factor and a positive scale factor comes into play when you're on the coordinate plane. When it's negative, it's telling you that the image is on the opposite side of the center of dilation. Whereas when it is positive, it is going to be on the same side of the center of dilation. The pre-image and the image, same side, positive, different sides when it's negative. And also when it's negative, it flips. If you notice where the A prime, C prime, D prime, C prime, and D prime are, this rectangle is actually flipped and on the other side of the center of dilation. Question 4. Using trapezoid ABCD as the pre-image and the origin at the center of dilation, which of the following is not a coordinate of a dilation on this image using a scale factor of -2? And again, the center of dilation for this is the origin. Now that you've answered that question, I just wanted you to take a quick look and see that with the -2 scale factor, I can multiply my pre-image coordinates by -2 to get my image coordinates. And these are the 4 that were correctly coordinates of the image. And I also put the lines here connecting the corresponding vertices of the pre-image and the image so that you can see that because the scale factor was at -2, that the image was on the opposite side of the center of dilation, which is the origin where all those lines intersected, the point of intersection of those lines, and it was flipped. Question 5. Determine the scale factor for the dilation depicted in the figure below. Dilations on the coordinate plane. Okay, again, this works when the center of dilation is at the origin. Because we've already determined that you can use the scale factor to get the points of the pre-image and the scale factor to find the points of the corresponding points on the image. Well, we can do that in reverse. If you're given the coordinates of a corresponding points on the image and pre-image, we can use the coordinates to find the scale factor. So without knowing the lengths of the sides of the figures, we can actually calculate the scale factor. So we can do the x-coordinate of the image over the x-coordinate of the pre-image, and we could try the y-coordinate of the image over the y-coordinate of the pre-image. Regardless of which you do, you should get the same scale factor. You notice here I just said in a different notation. If xy is your pre-image, x prime, y prime is your image. So you're going to do x prime divided by x equals your scale factor t, or y prime divided by y equals your scale factor t. Under a dilation with the center of dilation at the origin, what is the scale factor when 0.25 is moved to 1025? Is quadrilateral DEFG similar to MNOP? Step 1. Are all the corresponding angles congruent? Yes, they are. Step 2. Are all the corresponding sides proportional? Well, in order to determine that, we are going to set up the ratio comparing the corresponding sides. So DE to MN, EF to NO, FG to OP, GD to PM. Insert the values, the measures of those side lengths. Reduce. Are the ratios the same? Yes, they are. So since the ratios are the same, the corresponding sides are proportional. And since they are proportional and the corresponding angles are congruent, then they are similar figures. Question 6. Are the pentagons similar? To find a missing angle and side measure for similar polygons. So these are the steps that you would use to try to determine the angle measures or side measures when you have two similar figures. So if you're trying to find the missing angle measures, you're going to want to identify the corresponding angles. And you do that by using the similarity statement. The order of the letters in the similarity statement match up the corresponding angles. Then you can find missing angle measures using the fact that corresponding angles are congruent, because we already know they're similar. Sometimes you might have to find a missing angle measure and using other theorems or postulates or definitions. For example, with triangles, we can use the triangle sum theorem, which states all angles add up to 180 degrees. So if we're given two angle measures, we can find the third missing angle measure. When you want to find missing side measures, we want to set up a proportion. A proportion is two ratios equal to each other. And when there are similar figures, we know the corresponding sides, right, are proportional. They have the same ratio. So you're going to use the congruent statement or picture so you can identify the corresponding sides. Set up a proportion, two ratios equal to each other, cross multiply. The extremes equal the product of the means equals the products of the extremes, cross multiply, and then solve for the unknown. Given that triangle ABC is similar to DEF, and measure of angle B is 65, and the measure of angle D is 20, what is the measure of angle C? Question number 8. Given that triangle ABC is similar to triangle ADEF, and AB is 8 meters, DE is 32 meters, and EF is 12 meters, and DF is 22 meters, find the measure of BC. These are the three similarity statements, postulates, or theorems that we learned regarding similar figures. Okay? In the angle-angle similarity postulate, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So angle K is congruent to angle R, and angle L is congruent to angle S. So that is enough to say that these two triangles are similar. Side-side-side similarity theorem. If three sides of one triangle are proportional to three sides of another triangle, then the triangles are similar. So in this case, we would match up the corresponding sides, HG to KL, KJ, sorry, GI to JL, IH to LK. We would then insert the values of those, the lengths of those segments, and compare the ratios. And in this case, they are all 3 to 1. So therefore, side, 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 three sides, proportionate. These triangles are similar. And the third and final one is side angle side. If two sides of one triangle are proportionate to two sides of another triangle, and in this case, 5.4 to 1.8 is equal to 4.5 over 1.5, which is 3 to 1, and they're included angles. So the angle that is formed by those two corresponding sides, proportional sides, so IG and HG and LJ and KJ, those included angles are congruent. Then that is enough to say the triangles are similar. That's side angle side. So what is the theorem that allows you to state that triangle DEF is similar to GHJ? Question number 10 and final question. Are triangles DEF and JKL similar? If so, by what postulate theorem?